Hello and welcome to an algebra tutorial video learning about solving linear systems of equations. In this video, I really want to take some time to think about the different methods we have of solving a linear system and when it might not be the best to use which method, kind of taking a look at which method might be the best for whatever we're trying to solve. All right, so the three methods we got are graphing, the substitution method, and the elimination method. Let's first talk a little bit about graphing. So graphing, in this day and age with technology, you should have a graphing calculator, such as like a TI-83, TI-84. But if you don't, there are actually free programs out there. The one I would recommend would be desmos.com. If you go to that website and look for their calculator, they really have a great one online for free that you can use. And you can put in two equations, you can click, find the intersection. There's no reason why in this day and age we shouldn't be graphing every linear system and just getting a good visual of what's going on. And that gets it kind of into the strengths of graphing. It's quick, it's easy to kind of see a solution or to see what's happening with our linear system. And if we have technology available, all we just need is the technology. It's not as fun to do it by hand, although we know how to do hand graphing and that can kind of be helpful as well. So those are some of the strengths of graphing. The weakness is, even if we're using technology, even if we're using a calculator or a computer to solve for that intersection point for us, it still does not give exact answers all the time. So we're not always exact. And what I mean by that is, say if we have a solution that has some really kind of weird fraction involved. For example, say the x variable was 5 and 13/97. That's a really weird decimal. That's an exact number, 5 and 13/97. But if I rely on a calculator to calculate using all the programming methods, it's going to give me just a decimal approximation. So the decimal might be nice. I might get like 5.1312 something, but it's going to round it at some point. I'm not going to give the exact value. I'm not going to get that exact fraction. So it's kind of the weakness of working with a graph, is it's not always exact. And sometimes we want exact. Sometimes it's better. All right, so now let's look at the substitution method or the elimination method. To help kind of illustrate which one, I actually put a couple of different linear systems there just to make it really obvious when we might use one method or the other. First of all, both of them both substitution and elimination are algebraic methods that where we crunch it out, we're able to get exact solutions. So I'm going to put exact down here because both methods are able to get exact solutions. That's kind of what separates them from graphing. Takes a little bit longer, but exact is nice. All right, so on this left one over here, look how it's set up. I've got 3y minus 5x equals 28 for my first equation. But on the bottom one, I got x equals 2y plus 1. Well, this one is actually set up to use substitution really well. And if you think back on the substitution method, it was taking, the first step we want to do is get one variable isolated all by itself. I've got that right here with x equals 2y plus 1. So it's already set up to use substitution. I can take that 2y plus 1 and substitute it in for the other x value and end up with this nice big equation that I can then solve out. So substitution is really nice if you have a variable already isolated. That would be when you would want to use substitution because, again, it's less work to already kind of get to that point. It's already set up. If I tried to use elimination with this one, I would have a lot of work to do to get it set up before I could even start adding my equations together. All right, well, let's look at this other one on the right here. If the left one was a good example of when to use substitution, this one's a good example of when to use elimination. So elimination method is where I add my equations together. Usually the first step we want to do is get them in standard form. Standard form being that whole ax plus by equals c. I want to get everything all lined up nicely, my like terms, so that when I add my x terms, add my y terms, add my constants together, it's really easy to do that. So now you may say, hey, look, this one's not lined up. The x's are lined up, but my equal sign isn't lined up. I kind of did that just to show that sometimes things are not always perfect. However, this is still set up way easier to do elimination than it would be if I tried to use substitution. If I tried to get x by itself or y by itself somewhere, it would take me 2 or 3 steps. I would get some fractions. It might not be very pretty. But if I look in this one, all I need to do is move this 3y over, subtract 3y from both sides in that second equation, and I can get a whole new system here. So let's rewrite the whole new system. I still have 2x minus 9y equals 17. But now on the bottom, I've got 8x minus 3y equals 8. So it just took one step, and now things are lined up perfectly. I would probably actually play around with getting negative 9y and plus 9y, so I'd multiply the bottom by negative 3. But that's the whole point, is I want to get it to add. This took only one simple little step to get all my terms lined up in standard form to then start thinking about eliminating. All right, so elimination, use that when they're already in standard form or close to it. Now, this is not an end-all, be-all. Again, sometimes it'll be very clearly substitution. Sometimes it'll be very clearly elimination. Sometimes you may get a system that could go either way. And again, that's why we have a couple different methods. Some of you may even be better at one method than the other, or like one method better than the other. It's just kind of stuff to think about as you're working with linear systems of equations. And I hope this is helpful for you guys as you're practicing this.